In this lesson, we'll talk about web services. Let's start with something we already know, the client-server architecture, which is used pretty much everywhere these days. Under this architecture, typically a client will send some data to a server. The server processes the data and returns some result. Now, let's imagine that we want to implement a client-server application. The application is quite simple. The client will send a username and a password to a server, and the server will check some database and see if the username and password match some user record. If there's a match, the server returns the information about the user, like name and age, and if there's no match, the server returns a message saying user not found. This is a very simple application, but unfortunately, implementing the networking part of the application is not so simple. If you have done socket programming before, you know that you need to write some code like this on the client side. You have to create a socket, you have to write a string to the socket and another string to the socket, one for username, one for password. Then you read a string from the socket. And depending on what the string you read, if it says user not found, then you need to return a null. And if it's not, then you create a new user object by reading a string from the socket, which is the first name, then the last name, and then the age of the user. And then you need to close the socket. And on the server side, it's even more complex. Not only you need to create a socket, you need to create a thread to listen to a port, and every time some data comes in, you have to spawn a new thread to process the data, so the main thread can keep listening to the port. And all this code just for something so simple like this. And it gets even worse. For every application, you have to design an application-specific data exchange protocol. What I mean by that is you have to design something that specifies what the data the client and the server expect from each other and how the data is interpreted. It's not something that can be reused for a different application, and sometimes it can be hard to get it right. For example, here, if a user's first name happens to be user not found, then the whole application can be messed up. Some really smart people looked at this problem and came up with a great solution. It's based on two very important observations. The first is that operations like this are just like function calls, where we pass some parameters like username and password, and the function returns a result like a user object or a null value. The second observation is that the data exchange between the client and the server is application independent. After all, it's just passing some strings and numbers and some combinations of them back and forth. So the networking part can be implemented as a reusable library, and this library can automatically pass the function parameters to the server and get the result back and return the result as the return value of the function. That idea led to the development of remote procedure call, or RPC, for the C programming language. Later, Java provided its own version of RPC called the Remote Method Invocation, or RMI, because, of course, in Java, functions are called methods, so it's no longer procedure call, it becomes method invocation. To use RMI, on the server side, we need to create an interface called a remote interface. And this interface declares the methods that can be called by clients. Of course, we also need to implement this interface, and the implementation is called a remote object. We then register the remote object with an RMI registry so a client can find it and use it. Now let's take a look at an example. Suppose we want to implement the user authentication operation we discussed here. And this is what we need on the server side. First, of course, we need a user class, and this is our data model class that has username, password, first name, last name, age. And notice that the rest of the class are just some getters and setters, and I also override the toString method. So when we print out a user object, it will print out the first name, last name, plus age. An important thing in this class is that it needs to implement the serializable interface that allows the server later on to send a user object back to the client. And we know that the serializable interface tells the Java virtual machine that that object can be serialized, or in other words, can be converted into binary format, transferred over the network, and then reconstructed from the binary format. And this is the remote interface. We only need to provide one method called authenticate. It takes a string username, a string password. And in RMI, remote interfaces needs to extend a super interface called RMI remote, and all the methods that need to be invoked remotely needs to throw the remote exception. We don't really need to care what's in remote and what remote exception does. For us, the main logic is simply this authentication method. Notice that I put both auth service interface and the user model class under the package common, and it means that these two files needs to be on both the client side and the server side. They are used by both the client and the server. And on the server, there are also two other classes. One is, of course, the actual implementation of the service interface. This here is called the auth service implementation, and this is the so-called remote object in RMI. And again, this remote object needs to inherit from a superclass. And again, we don't really need to care what the superclass does. Similar to when we do serverless, we don't really need to care about what the superclass serverless does. And the important thing is this implementation needs to implement the service interface, this auth service, and then it needs to implement the authenticate method. Now, typically when we do authentication, we would use some database or directory service, and for simplicity's sake, I'm just creating an array of users and then authenticate against this array. And in this array, I only have two user objects, JDO1, JDO2, A, B, C, D, and then name and then age. And in the authenticate method, we take username password. We go through the list of users, check username password. If a user is found, we return the user object. Otherwise, we return null. So then we have implemented the service, and in order to use that, we have to register the service with a RMI registry. So this code will create a RMI registry, which is essentially a service running on this computer, and the number 4048 here is a port number used by that registry service. And to register my remote object, we simply give it a name and then create a remote object and then say registry rebind, and this will register this service with this registry under this name. So if we run this code, and it runs here, there's no output because the actual calling of the method will be on the client side. On the client side, the code is actually pretty simple. It just need to connect to the registry, look up the service by name, and then of course invoke the method. And the client code is here. So first we locate the registry by specifying the host name, which is this computer, localhost, and then the port number. And once we locate the registry, we do a lookup by the service name. It's called auth service. It's the same name when we register the service. So we get the service, and then we simply call the service by invoking the authenticate method. And if the return value is not null, we print out the user. If it is null, it prints out user not found. So we can run this code, and it prints out John Doe if we give it a wrong password, and it prints out user not found. If it's 1, 2, 3, 4, JDO2, it prints out JDO. So the code, of course, works. To stop the server, let's go back to here and here. Okay, so this is a simple example of RMI, but more importantly, we need to understand how RMI works, and it's shown in this diagram. So on the server side, we first create a remote object. We then register that remote object with a registry, and this part is clear. And then the client will look up that service by doing a registry lookup, and this step, this step corresponds to this line of code. Now, the key thing about understanding RMI is to understand step number 2. So, in particular, the question is when we do a registry lookup by name, it returns an object. And the question is, what does it actually return? Now, we'll say registry lookup, and it returns an object that implements its auth service interface, and many people will say, okay, then it returns this remote object, and then the client can call that remote object. And that understanding is incorrect. This lookup, or the step 2 in the diagram, does not return the remote object. The reason is that if you think about it, you know that the remote object resides on the server, and chances are it needs to rely on some resources on the server to function. For example, in our example, it may need to access a database on the server to authenticate a user. So simply downloading this remote object to the client won't make it work. What registry lookup actually returns is something that also implements the same auth service interface, but it's not the remote object. And that something is usually called a stub or a proxy. If you remember our discussion about aspect-oriented programming, you know what a proxy is. It implements the same interface as the remote object, so the client code can call the same methods, like here. And but it's not the actual remote object. What the stub or proxy does here is that it will pass the method parameters to the server, and so that the actual remote object can use the parameters, invoke the method, and produce the result. And then the stub or proxy gets the result from the server and then return the result to the client code. So the whole thing is actually not very difficult to understand, but the key again here is to understand that when you do a registry lookup, you are getting a stub or a proxy. It's not the actual remote object, and the stub or proxy will handle the underlying network communication between the server and the client, but giving the sense of a local method invocation to the client code. As we can see, RPC and the RMI are pretty great. We no longer have to deal with tedious networking code, and client server operations become as simple as method calls. The only problem is that RPC and RMI require the client and the server to use the same programming language. So naturally, we start thinking that can we create a cross-platform RPC where the server and the client can use different languages? In theory, this should be quite possible because the data exchanged between client and server are essentially just some strings and numbers, and every programming language can deal with strings and numbers. So there's really no reason why we cannot implement the service on the server using one language, then let the client to use any language it wants to access the service. Well, there's only one problem. If we go back to our RMI example here, we can see that the reason why the client code is so simple is because the client shares the same data model class user and the same service interface with the server, so the client can use the data model class here, and then the service interface here. Now, imagine that the server is implemented in another language, then we no longer have this and this. Or in other words, we no longer have a Java API the client can use to make the method call. So what do we do then? One solution people came up with is CORBA, which stands for Common Object Request Broker Architecture. It's basically cross-platform RPC, and a key part of it is a interface definition language, or IDL. It's a language specifically used to describe service interfaces, and a service interface described in this language can then be translated into other programming languages, like an interface in Java or a header file in C or C++. Here's an IDL example about some hypothetical banking service. You can see that it defines an exception class and some operations like checking account balance, getting the name and address of the account owner, setting account balance or setting account address, and so on. For a while, CORBA was quite popular, but for various reasons, it became obsolete. There's an interesting article called The Rise and Fall of CORBA. You can check it out after class if you are interested. Now, let's get back to web services, which is supposed to be the subject of this lesson. Why do we discuss things like RPC, RMI, and CORBA when we should be talking about web services? Well, because web services is just RPC over HTTP. And it's called web services because the data exchange between client and server uses HTTP requests and responses. There are 2 points I want to further clarify. First, notice that I call this traditional web services, because later we'll talk about another type of web services called the RESTful Web Services, which conceptually is quite a bit different from traditional web services. And secondly, the term web service is an umbrella term that covers many protocols, specifications, and technologies. You can categorize them by language, whether they support a single language or they are language independent, and by message encoding, whether the data exchanged between client and server is in binary format or text format. Of all the traditional web services, the most commonly used is SOAP, which stands for Simple Object Access Protocol. Next, we'll see an example of implementing and using a SOAP web service. Excuse me. Implementing SOAP web service used to be very tedious work, which is one of the reasons why lots of people hated it. Fortunately, in the last few years, the libraries have improved a lot, and the best one, in my opinion, is a Metro library provided by Sun, which is now part of Oracle. Metro implements the latest Java web service specifications, and it also guarantees interoperability with Microsoft's Windows Communication Foundation web services. And the most important of all is, as we'll see in a moment, it's very easy to use. There are also some other web service libraries you can use, especially if you are an open source purist and prefer something not controlled by large corporations. You may want to try Access2 or CXF. I used Access before and didn't quite like it, but I can't really comment on Access2 or CXF, so this is mainly just for your information. Now let's see a web service example using the Metro library. So the first thing is, of course, the dependency. So this is a dependency for the Metro library. The group ID is all Glassfish Metro, and the artifact ID is web service -RT, probably stands for runtime. Now, here. Okay, so let's say we want to provide a web service, and this web service will provide two operations. One operation is called MD5. It will take a string and encrypt the string using the MD5 algorithm and return the encrypted text. And the second operation does similar things, except that it will encrypt the string using the security hash algorithm 1 or SHA1 algorithm. I can implement those two methods like this, and it's using this message digest class provided by the Java security package. Exactly how the API of message digest works, that's not really important. The important thing here is that we can implement those two methods as regular Java methods. Right? If you look at here, there's nothing here that says anything about a web. There's no web servlet, there's no JSP. This is essentially a regular Java class with a few regular Java methods. And there's a method called MD5, which takes a string and then encrypt it and return the encrypted MD5 digest of the string. And similarly, SHA1 encrypt the input with the SHA1 algorithm and return the encrypted text. So the first thing we notice is that to implement a web service, it's pretty straightforward. You implement it as a just as regular Java classes and methods. Then what you do is you put a couple of annotations in there. You'll say, okay, this class is a class that provides web service, and this method is one of the method or one of the application operations provided by the web service. This is another web method, and that's more or less it. That's all we need to do in terms of actually writing the code. There's no need to create servlets or anything like that. Now, we do need to do a little bit more in terms of configuration. So the whole thing is created as a web project, although we don't really need to write any web code. Like I said, we don't need to write servlets and so on. But the whole thing is still configured as a web project, and of course, then for that we have a web.xml file. Now, inside this web.xml file, we specify a index.html. It's just a regular HTML file for convenience purpose that I put in there. The important thing is this listener class. Notice that this is a class provided by the web service library, and it's a context listener which is used to load additional configuration files, and that additional configuration file is this one called sum-jax.ws, and inside here we specify the name of our web service, the class that implements that web service, which is this one, and then we specify a URL pattern, which means where that web service can be accessed. And this is pretty much all we need to do in order to provide a web service. Again, as we can see, it's pretty straightforward. All you need to do is implement the operations as regular Java, put in a couple of annotations, and give the web service a name and a URL, and then you put it on a server, and you'll have a web service running. So my computer is still slow. Come on. Okay, so this is the index.html. I have a link there. I click on it and it goes to here. Notice the URL/hash, which is the URL we specified here. So this is basically the entry point for the web service. Now, if you have never used a web service before, at this point you may feel a little lost. So this page displays some information about the web service, great, but how are we supposed to proceed? Or in other words, how do we use this web service? Well, the key is here, the WSDL document. This one. WSDL stands for Web Service Definition Language. It basically serves the same purpose as IDF in CORBA, which means it's basically a language that describes the API of the web service. When you see a WSDL document like this for the first time, it can be a little overwhelming. There's a bunch of text there. Even for a simple service like what we have, which really is a pretty simple service, the WSDL document can look quite complex. But once you understand the basics, it's actually not very hard to read and understand it. Now imagine that we want to let's say, design our own WSDL language to describe service APIs. API is essentially like a Java interface, right? It's something that defines the method signatures without the actual implementation. So imagine we want to design our own WSDL. So what we do is we start with a Java interface like this, and then we see what elements in a Java interface we need to describe in order to describe this whole interface. Well, the first thing we notice is that we have to be able to specify the name of the interface, like foo here, right? And then we have to be able to specify data types, like integers, strings, and big decimals. And then we have to specify what are the parameters of a method and what is the return value of a method. And then, of course, we need to be able to specify what the name of the method is. So, in other words, if you look at an interface or API, these are pretty much all we need in order to describe it. So once we understand that, it's quite easy to understand a WSDL document. For example, if you look at the document, it has something that says port. Let me open this in Firefox. Probably make it easier to read. So it has something called port type, and that essentially is the name of the interface. And here it says port type is HashService, and that's essentially our interface name. And then if you want to know what operations or what methods are there in the interface, you look for operation, and here it says operation name MD5 and operation SHA1. So we know that, okay, there are two methods in there. And for parameters and return values, we look inside the operation, we see input and output, and input and output. So we know that, okay, this is the parameter, and this is the return value, and in fact it also has a fault, meaning that it will be able to throw an exception. So then we look at the message, which is supposed to be the input value, and we also have output value and so on. And we see that the type of the input parameter is MD5. The return value type is MD5 response. So what are those things? Well, those things are essentially types. So if you want to see the types for this web service, then go to the URL for the schema location. And here you'll see that MD5 message is essentially a string, and MD5 response message or MD5 response type is essentially also a string, and so on and so forth. But once you kind of understand the basics, what is needed in order to describe an API, and what those tags corresponds to in terms of a regular Java interface API, then reading the WSDL document is pretty easy actually. If we look past all the XML and WSDL syntax, it's really just an API like this. Okay. So we understand what a WSDL document is. Then how can we use this web service from the client side? as you would expect, there should be some tool that takes a WSDL document and then automatically translate it into some code that can be used by clients. Metro, in fact, provides several of those type of tools, and one of them is in the form of a Maven plugin called the WS import. If you look at the POM file here, you can see that we have included a plugin from the Metro library, and that plugin has a goal called the WS import. We bound the goal to generate sources phase of Maven build lifecycle because this goal is going to be used to translate a WSDL document into some Java source code files that can be used by the client. So naturally, it should be performed during the generate sources phase of the build cycle. And to make this thing work, we need to tell this goal where the WSDL document is, and this is a URL for the WSDL document, which we just saw. And we also need to tell this goal where the generated sources should be placed, and we say it needs to be placed under this package cs520.ws.client, and that is basically here. Right now there's only one file in that package, and I commented out all the code because it relies on the generated source, which we haven't generated yet. Okay, so we have all those, and then let's run the plugin. So we will say run as Maven build. It's in the phase of generate sources, and we'll say WSDL to Java. Apply run. Okay, so we can see that it generated a bunch of Java source code files. If I do a refresh here, you can see that now we have all those files in there. Now, among those files, two files are particularly important. One is this HashService, and as you can see, it creates the HashService interface, and this one is similar to the auth interface we used in the RMI example, but notice that now this can be automatically generated from the WSDL document. In other words, on the server side, we don't exactly care what language is used to provide that web service. As long as that web service has a WSDL document, we can generate Java interface out of that document. The second important class is this HashService service class, and this is essentially the stub that we are going to use to invoke the methods, and this stub class will be responsible for sending the parameters to the server and getting the results back. So once those files are generated, now we can comment out we can uncomment the code. So as you can see here, we are creating a hash service using the interface as the type, and the actual object is HashService service. As I mentioned, that's the actual that's the one that that provides the stub or the proxy to the actual web service on the server, and then we can invoke the two methods MD5 and SHA1, and we can run this, and it shows the encoded form of ABCD in MD5 and in SHA1. So if we stop the server and then run this code again, it will give us an exception saying fail to access and connection refused. And this tells us that these two methods are indeed invoked on the server side, not some local methods that I created to try to trick you. Once we stop the server, these two won't work anymore. Okay, moving on. What we've seen is so-called SOAP web service, and now let's talk a little bit about SOAP itself. SOAP basically defines the format of the data exchanged between the client and server. This is a simple SOAP message sent from a client to a server. The message is to invoke a do spelling in suggestion web service Google used to provide. You can see the method takes two parameters, access key and string phrase. Here the phrase is misspelled Britney Spears, and for those of you who are too young, Britney Spears used to be a big pop star. And this is the response message from the web service, which returns a correct spelling of Britney Spears. And here's an exception message if some error happens. SOAP is built on top of some other XML standards. In particular, it uses XML schema for data types. And here are some examples of common data types and how they are used in SOAP. For example, here's an integer. In SOAP, it will be written like this, and here's a floating point number. In SOAP, it's written like this, and here's a string, and this is what a string looks like in SOAP. And more complex data types like arrays and composite types can also be represented. But as we can see, SOAP, although stands for Simple Object Access Protocol, is actually quite complicated, and even worse, as a data exchange protocol, it really doesn't exchange data very efficiently. For example, here in this request, there are only three things that are useful: the name of the operation and then the two parameters. But in order to transfer these three things, SOAP requires that we include a whole bunch of other stuff, which is obviously not very efficient. And this is one of the reasons why SOAP web services are used less and less these days. When people talk about SOAP and WSDL, they often mention a third protocol, UDDI. UDDI stands for Universal Description, Discovery, and Integration. Remember, in RMI, we can register a service with a registry so clients can look up the service in the registry. UDDI basically specifies how to create a registry for web services and how to publish, search, and manage web services in the registry. The idea of UDDI is not bad. Basically, people create web services and they want other people to use their web services. so they can publish their web services in a registry where other people can find them. The registries can be public, private, or semi-private to suit different situations. In practice, however, the idea doesn't quite work. I think the reason is that nobody wants to use a web service they just find in a registry, because who knows what the web service actually does. On the other hand, if you already know and trust a web service, you can use it directly without going through a registry. So in practice, UDDI registries, particularly public UDDI registries, were never very useful. There used to be two public UDDI registries, one run by Microsoft and one run by IBM. Both were filled with Hello World type of web services, probably written by students who were taking web service classes. I think both registries were shut down years ago. SOAP, WSDL, and UDDI are kind of the three pillars of the traditional web services. These days, the popularity of traditional web services, particularly SOAP, has decreased dramatically. There are two simple reasons. They are too complex and they are not very efficient. We saw in our SOAP message example that the format is just not very efficient. We have to use a big message to send a few simple values. And also the protocol is very complex and rely on a number of complex XML specifications. This makes creating supporting libraries very difficult, and without supporting libraries, it's almost impossible to write web services. So this takes us to the second type of web services, the so-called RESTful Web Services. Suppose we have a RESTful web service that lets clients to get the information about a user given the user ID. This would be what the service look like. We can send a HTTP request to a certain URL, like service/user/1, and the web service will send back an HTTP response which includes the information about the user with ID 1, and the information is typically encoded either in XML or in JSON format. At this point, you may be asking, is that really a web service? In particular, we were talking about web services being RPC over HTTP. So first of all, where is the method call? And secondly, if we look at what's happening here, it looks very much like a web application. So why does a web service look like a web application? Shouldn't a web service being something quite a bit different? And the third question, of course, is why it's called RESTful. Now, for the first question, the answer is that yes, it is actually kind of a method call. If you think of this URL, the /service/user, as the method name, and this part of the URL being the parameter, and the HTTP response being the return value, then this whole thing is kind of a method call. Of course, there's a big difference between this and a traditional web service, and the difference is now it's the client's responsibility to convert a HTTP response into a return value. And that's the reason why RESTful web services usually return XML or JSON responses, because objects can be naturally encoded in those formats, as shown here and here. And parsers for XML and JSON formats are readily available for many different programming languages. The second question is, why does it look like a web application? In fact, the only difference here seems to be that a web application would return HTML, while a RESTful web service returns typically either XML or JSON or both. The answer is that yes, indeed, it looks like a web application, and it is a good thing. Because now all web technologies and languages like PHP, Ruby, Python, or whatever can be used to create web services, and you no longer need to implement very complex specifications like SOAP and XML schema and so on. So if creating it as a web application gets a job done, then why not? The third question is, okay, then why is it called RESTful? Well, it comes from the term REST, which is a shorthand form of representational state transfer. The term was introduced by Royal Fielding in his PhD dissertation on network-based software architecture, and it's used to describe the common characteristics of scalable, maintainable, and efficient distributed software systems. A REST system must meet the following requirements. It must use a client-server architecture. It must be stateless. It must support caching. The resources in the system must be uniformly accessible, for example, using a URL or a URI. And it must use a layered architecture, and optionally, it should support code on demand like Java applets. So what are RESTful web services? If we say traditional web services are RPC over HTTP, then RESTful web services are basically web applications for programs. They can be built in pretty much the same way as building a web application, except that the responses are supposed to be consumed by programs rather than by human beings. And that's why the responses of a RESTful web service is usually in XML or JSON format, while the responses of a web application is usually in HTML. Another very important characteristic of RESTful web services is that they try to simulate how static web works. If you look at the REST requirements here, you can see that it's pretty much a description of the static web, which is basically the largest REST system that we know of. RESTful web services try to simulate static web in several ways. For example, using URLs that look like URLs for static web pages. In other words, using path variables instead of request parameters. And it would utilize HTML request methods like get, post, put, delete, and so on to represent certain operations. And very importantly, it needs to be stateless, or in other words, not keeping sessions. And this is why I keep saying static web, because unlike web applications, static web is stateless, and that's an important reason why static web is super efficient and scalable. Now, suppose we want to design a RESTful web service that provides some user management operations, like list all users, get a particular user, add a user, update and delete a user. Here are the list of things we need to do when we create a RESTful web service. We first need to identify the resources and operations. Here we kind of already did that. Our resource is, of course, the user records or user objects, and operations are list, get, add, update, delete. So once we identify resources and operations, we need to determine the resource representation, meaning the data exchange format between the service and the clients. And once we chose that, we design the URL and request mapping for those operations, and then we, of course, implement those operations. For resource representation, the main criterion is that the data format should be easily understandable by all programming languages. In practice, it basically means either XML or JSON. For XML, it's already widely used as a platform-independent data exchange format, and XML parsers are readily available in many languages. For JSON, the advantage is that it's much more concise than XML, and also it can be used directly in JavaScript. So if your web service, if your RESTful web service is used as the server side of AJAX operations, then naturally you probably would want to choose JSON. So all in all, JSON seems to be more popular these days than XML, and if you are unsure, you can always provide both, which is, as we'll see later, not all that difficult to do. When you design URL and request mapping for the web service, you should follow certain conventions. For example, the URL for the get user operation can be either this one or this one. The path variable-based design is usually preferred because it looks more like static web, or in other words, it's more quote-unquote RESTful. If we provide both XML and JSON response, we can let the client to choose which format they want by either using a suffix pattern like this, or using the accept header in the request. The accept header way is in theory the slightly more RESTful way, but in practice the suffix pattern in URL is probably more convenient to use. So either way is okay. In addition to use URL patterns, RESTful web services usually map different request methods to different operations. For example, the get method is usually mapped to the retrieve operation, and the delete request method is usually mapped to the delete operation. The mappings of get and delete are fairly obvious, but different people seem to have different interpretations of post and put. Personally, I think post should be mapped to create, and the put should be mapped to update. But if you do it the other way around, it's okay too. And these are a few examples of request methods mapped to different operations. Notice that in all three cases, the URL are the same, and it's the request methods that determine what operation should be performed. If you send a get request, it will retrieve the user with ID 1. If you send a delete request, it will delete the user with ID 1. If you send an update request or a put request, it will update the user with ID 1. And if you do that, then you should also send the data that will be used to update the user. And this part of the data is, of course, encoded in the request body. So this is typically how we can design a RESTful web service. And once we finish the design, we can implement it, and the implementation is actually kind of easy because, like I said, RESTful web services are just like web applications, and we know how to build web applications. And eventually it comes down to use good libraries and know your libraries. There are two types of libraries you'll need. The first type helps you map requests to service operations, and any modern web application framework like Spring can do that. If you are not using any framework, you can use this library called Jersey to help with request mapping. The second type of libraries are the ones that help converting between Java objects and XML or JSON representations. The conversion is known as serialization, going from Java object to text, and deserialization, going from text to object. There are many libraries for this. We'll see a couple of examples using this library called Simple XML Serialization and this one called Jackson. So let me first run that web service, and then we'll explain how it's implemented. Okay, so let's again first look at the dependencies. If you look at the dependencies, you can see that we have our regular Spring dependencies, Hibernate, database, and all that. There are 3 new dependencies here. The first one is called Jackson, and this is this library, and this library does serialization and deserialization between Java objects and JSON. The second dependency is called Simple XML, and it's this one, and this one does serialization and deserialization between Java objects and the XML. There's a third one called HTTP client, which is a library we use in standalone Java programs to access web services, which we'll talk a little bit about once we get to the client part. Now, the project itself, as I mentioned, is a pretty standard Spring Web MVC project. We have our model class, which is the user, and we have our Hibernate-based DAO implementations, which does get user by ID from the database, get all the users, save a user, and so on. And we also have our controller here. But notice that although this one is implemented as a controller, but now we're doing web service instead of web application. So although it's implemented as a controller, if you look down at each controller method, you'll notice that none of them return any JSP or HTML response. Some of them will return XML, and some of them will return JSON. And so let's look at an example here. For example, oh, I think I didn't create my database, so let me do that. So it's looking for a database called RESTWS. Okay, let's do that. CS520 workspace RESTWS. Create the database RESTWS. RESTWS source line scripts. Create. Okay, so this creates a database, and let's see what's in there. Okay, so we have 2 users, John Doe and Jane Doe, and Okay, so first notice the URL here. So when we go to this URL /service/user/1, it returns the user with ID 1, and if we change this to 2, it returns the user with ID 2, and this one will return the users in XML format, and that's this one. And if we go to one.json, it will return the user in JSON format, and 2.json will give us user number 2. So if we look at the implementation, so this one is handled by this controller method. So what it does is it gets the user from the database and then return a view. If we look at the view, it looks like this. So this is the first way we can return an XML response. We simply create the XML page using a JSP. Right? Notice that here it's not an HTML page, it's an XML page. And inside the XML, we have a user tag and then ID tag, and then we put user ID, first name, last name, and email in here, and that's what it looks like here. Now this is the first way of doing things. Now the second way, which is when we say one.xml, it looks pretty much the same as the first, but the actual implementation is different. So this one is handled by this controller method. And this controller method, again, will retrieve the user object from the database, and then it will use simple XML serialization to serialize the object into a string, and then we write the string directly into the response. So notice that this one doesn't return a view name. It writes the XML directly into the response using serializer and the persistor. And if you look at the import, so serializer is here, persistor is here, and both are from the simple XML serialization library. So this is the second way of generating XML. You use that library to serialize the object directly. Now to generate JSON response is we go to one.json, and that one is handled by this. Now this is something kind of interesting. So notice that in this controller method, we again retrieve the user from the database, and then we return something called a JSON view. If you look at our view, JSON view is actually not a JSP. We don't have any JSP called JSON view here, only something called get user. Right? So what's happening here? What's happening here is that we are actually using two view resolvers here. So here we have internal resource view resolver, and this one is used to resolve JSP pages. And we also have something called a bin name view resolver, and we have a bin called JSON view. And what this one does is when we return a view name called JSON, it will pass that to this bin, and this bin will take whatever model objects we put into model map, and automatically converts those model objects into JSON format, which is what we see here. The important thing, well, there are two important things here. First is this mapping Jackson to JSON view. As I mentioned, this is a bin provided by Spring, and it utilizes the Jackson library. And what this view does is it automatically translates all the objects in the model map into JSON representation like this. The second important thing is how to specify multiple view resolvers in Spring, and it's something allowed. And Spring will first try this resolver, and if this resolver cannot resolve a view, it will try the next resolver. So to specify the order of the view resolvers, you can either specify them in the right order in the configuration file, or you can use order attribute to specify the order so that you don't have to list them in a specific order. In any case, the internal resource view resolver must be the last, because it always resolves to a view. Even if a JSP doesn't exist, it will return a full view. So if you put this resolver before some other view resolvers will never be reached. So going back to the code, you can kind of see how view resolution works. If it returns a view name called get user, it will first try this bin name view resolver, and it will look for a bin called get user. Of course, there's no such bin, and then it will pass the name to the second view resolver. Now, if the view name is JSON view, and this view resolver will look for a bin called JSON view, and it will find this bin. It will pass the request to this bin, and this bin will convert the model objects into JSON like this. So this is how the server side works, and by and large, as you can see, it really is pretty much the same as how we create Spring MVC applications, and the only main difference is the response. And for RESTful Web Services, the responses should be either in XML format or in JSON format. Okay, so creating RESTful Web Services are not difficult. We already know how to develop web applications, and we know all the tricks. And the next question is then, how do we write client code to use them? Well, as I mentioned, one of the most common usage of RESTful Web Services is to provide the server end of AJAX operations. And in that case, the client code is in JavaScript. Suppose the web service sends back JSON responses, then you don't need any additional library, because JSON can be used directly as objects in JavaScript. But let's say instead of doing AJAX, we want to write some standalone code that access RESTful Web Services, like some mobile apps. Then we'll need a library that can talk HTTP to a web server. And for Java, you can use the Apache HTTP client library, which is the dependency I showed before, which is this one. And for Android apps, the recommended class is HTTP URL connection provided by the Android Development Toolkit. Here I have a couple of examples using standalone Java program. So this one will use the JSON interface of the web service we created. As you can see, it includes a couple of classes from the Jackson library that does conversion from Jackson to Java objects. The one that's particularly important is this object mapper, which does the conversion. Most of the code is used to make HTTP connections, get the response, get the body content of the response, and so on. So, for example, this part would send a request to the web service at this location, and it sends the request to the JSON URL pattern. So we get a JSON response, and once we get the response, we get the response body, and then we use the object mapper to convert that response body into a Java object, and that Java object is a map because the JSON view will convert all the model objects in the model map into a map, and the map key is the name of the model attribute, and then of course the value is the model attribute itself. So we get the result, and then we use the user as a key to get the user object, and then we can print it out, and then we can close the connection. And the second part is very similar, except that it uses another URL to get all the users. So if we run this code, it should work. Yeah. So this one is this part, which gets the user with ID 1, and these two lines are printed out after we retrieve all the users, which we only have 2. This program is very similar, except that it uses the XML response of the web service instead of JSON response. And I'm not going through the details of the code. It's really, again, just about using the HTTP client library and the XML, simple XML serialization library. And let's just run it and make sure it actually works. The details you can always check the code after class. Okay, so this is how we can use our so-called consumer web service. Really, it's just have some library or class that can speak HTTP with the server, and then once you get the response, you'll parse the response and then convert the response from either XML or JSON to your Java objects. And here's a quick summary of what we have covered. Basically, it's a big pot of alphabet soup. We have RPC and RMI, and then CORBA, and IDL, SOAP, WSDL, UDDI, and of course RESTful. And here are some additional readings if you are interested. By the way, there are lots of books on Java web services, but most of them are pretty outdated. So if you want to read any Java web service book, make sure it's a recent one. And this is the end of the lesson.